Welcome back to class. So today's lesson, actually going to be a couple different lessons. We're going to throw a bunch of stuff together, all right? But a really key for this is the first part of this lesson, because this first part where we're writing expressions, it's going to be used that's going to be a common thread running through this entire course. So make sure you really understand this first slide and how to do it, okay? Let's get started. What we're going to do is we're going to write algebraic expressions. Basically, what that's going to mean is you've got a bunch of problems that looks like an English class right now as you're looking at this, and what I want to do is I want to make it look like a math class, all right? So all we're going to do is write down what it says. Now, there are a couple tricks along the way that I'm going to teach you, and make sure you know those, but overall, I don't think it's going to be too tough. All right, so let's get started. The sum of 17 and a number, x. All right, so first of all, what does sum mean? Sum means, technically, it's the answer to an addition problem. I'm just going to say it means addition, right? So the sum of, so we're going to add what? Well, we're going to add, it says 17 and a number x. That's it. The sum of 17 and a number x. When it says a number x, don't get too caught up in that. That just means x, all right? The next one, 4 less than y. So let's just write what it says. 4 less than means minus y. Now, this is trick number 1, and this is something you have to see, otherwise it will be wrong, all right? You see the word than in here? Very, very important word. When you see than, it means that you have to flip things around, okay? So this is not 4 minus y. 4 less than y, we have to flip it around, and we actually have to say y minus 4, okay? So write it exactly like you read it. And then if you see a than, you have to flip it around. Let's look at the next one. The product of 8 and the sum of 4 and x. Hold on. Pay attention to this one, okay? Product means multiply. So what are the two things we're going to multiply? We're going to multiply 8 and a sum. The product of 8 and the sum. Okay, sum means plus, so that's why I put the plus there. So we're multiplying 8 times a plus. Just stick with me, okay? What are the two things we're going to add? The sum of what? Well, it says the sum of 4 and x. Okay, now there's one more thing there. So this kind of got a little bit out of order, okay? Because it's just a little bit messed up. When you see the product of a sum, okay, when we have a product of a sum, or the difference of a quotient, or the quotient of a sum, or something like that, when we have two of those numbers those words kind of together, they say we're going to have to add and divide, or multiply and add. When we have a couple of those things together, we're going to have to use parentheses, okay? That's the key, that we're going to have to use parentheses. So we're going to multiply a sum. Maybe let me erase this and start over with this one. So we have the product of, that's multiplying. Well, what are the two things we're going to multiply? We're going to multiply an 8 times a sum. What are we going to multiply? What's the sum of? 4 and x. So that's what that one is, and that one's tough. No doubt this one's tough. Okay, let's look at the last one. The quotient of, well, quotient means divide, and in algebra we're going to use a fraction bar to show division, okay? The quotient of, what are we going to divide? Well, the first thing we're going to divide is 17, and what are we going to divide on the bottom? The sum of, so that's a plus what? 13 and x. So we've got 13 and x. All right, so when you're doing these things, just write down what you read. If you see a than, like you did in the second one, you're going to have to flip it. And if you see those two process words together, like we're going to add and multiply, or divide and subtract, when you see those together, that's a big key. You are probably going to need to use some exponents, all right? Now, let's get into a couple other concepts. Like I said, we're throwing a couple lessons together. Let's talk about radicals and square roots. How are we going to use these? Okay, so the square root of 9. What is the square root of 9? Well, what that means is the square root means what number times itself is 9. Do you know what that is? What number times itself is 9? Yeah, 3 times 3 is 9. So the square root of 9 is just 3. Okay? All right, so let's look at the next one. What's the square root of 4 divided by 9? And you're thinking, you want me to take a square root of a fraction? Are you crazy? Well, this is kind of a special fraction. I gave you a special one. All we have to do is take the square root of the top and the square root of the bottom. So what's the square root of 4? What times itself is 4? Well, you know that. That's just 2. 2 times 2 is 4. And what's the square root of 9? We just talked about that one. The square root of 9 is just 3. So the square root of 4/9 is simply going to be 2/3. All right, let's look at this next one. The square root of 0.09. Okay, so the square root of a decimal is going to be a little bit harder, okay? I see the 9. I see the 9 is still in there, okay? So, what's the square root of 9? 3, right? Square root of 9 is 3. But that was a decimal up there. So what do you think is going to happen? We're going to actually have a decimal there. Done. That's it. And you're thinking, that's it? That's it. The square root of 0.09 is just 0.3. Hey, not bad. Let's look at this last one. Now, if this were second semester Algebra 1, I would show you a little bit more how to do this, okay? But right now, let's just say the square root of 28, all right? The square root of 28, if I use my calculator, let's use my calculator. Square root of 28 equals, you can't see this, but it says 5.29, right? So like that's a number that keeps going on, and it doesn't just stop at 0.29. This goes on to 5.2915026622, and it keeps going on forever. It doesn't stop. All right. This is a special kind of number and leads us right into the next part. This is called an irrational number. I'll get to more of that in a second. All right, there are different ways that we can classify numbers, that we can kind of name them. We're going to start with real numbers. Basically, a real number is anything you know, right? Like 2, 7, 18.3, 2.9765, 1.34968231579, whatever. All real numbers. Let me show you a number that's not real. Okay, let me show you a number that's not real. So basically, any number that you know is real, except for something. What's the square root of 9? The square root of 9 is 3 because 3 times 3 is 9. What's the square root of negative 9? Square root of negative 9, you might say it's negative 3, but I've got a question. What's negative 3 times negative 3? A negative times a negative is going to be a positive, which is not that. So we've got a problem. The square root of negative 9 actually doesn't exist. You can't take the square root of a negative number. So, just an introduction here. But every number that you know is real except for a square root of a negative number. And there's a very special square root of a negative number that we'll actually work a ton with in Algebra 2, some in Algebra 1 this year. But the square root of negative 1, that's an imaginary number, not a real number, that we just call I. I for imaginary, okay? So, just basically know. A real number is any number you know, all right? Except for those tricky negative square roots. All right, how about an integer? Integers, we also like those. So real numbers, 2, 5, 3.1415, just keeps on going. All real numbers. Integers, we love integers. Integers are numbers with no fractions and no decimals. 5, 3, 0, negative 12, negative 39. All right, all of those are integers because they don't have a fraction and they don't have a decimal. Okay, so those should be pretty easy to know. The last couple, rational and irrational. A rational number is any number that can be written as a fraction. So 5 is a rational number because I can write that as 5 over 1. 2/3 is a rational number. Okay, but now it's going to get, because it's written as a fraction, but now it's going to get a little bit more tricky. What about this? What about a decimal? 0.2. Well, that can be written as a fraction, 2 over 10. What about this one? 0.4 repeating. That can be written as a fraction too, 4 over 9. Okay? So rational numbers can be kind of tricky to spot. Instead of focusing on rational, why don't I show you an irrational number? Okay? Irrational numbers. So I'm going to erase these rational numbers. By the way, every integer is a rational number. Okay? Let's just look at irrational numbers now. An irrational number is a decimal that does not stop and does not repeat. 2.1423765 and just keeps going on forever. That's an irrational number. That's it. Okay? That's it. If a number is a decimal that does not stop and does not repeat, it is irrational. Okay? That's it. Now, sometimes these can hide in kind of tricky ways. Like we saw an irrational number in the last slide. Remember the square root of 28? Oh, I'm sorry, not square root of 29. Square root of 28. Square root of 28 was 5.29150262, and it kept going on forever. Didn't stop, didn't repeat. So square root of a number is one way that it can hide. So if this square root is not a perfect square, like 4 or 9 or 16 or 25 or all those perfect squares, if it's not a perfect square, it's going to be an irrational number. So that's one way it can hide. Another tricky way that it can hide is like this, pi. All right, and I know that's kind of sloppy down there, but that's the pi symbol. So an irrational number is a decimal that doesn't stop and doesn't repeat, and it can hide in a couple ways. It can hide as a square root, and it can also hide as pi. All right, but just make sure you know. Well, let me ask you another question. I want you to classify this number. What's the square root of 16? It's tricky. First of all, it's real, right? The square root of 16 exists. Is it rational or irrational? Well, it's a square root, so maybe it's going to be irrational. But what's the square root of 16 actually? That's actually going to be 4. So this is going to be a real. 4 is an integer, so the square root of 16 is also an integer. And every integer is a rational number. Okay? All right, so I know that was a lot of stuff, but I know you got it. Good luck.